Earthquakes have been occurring long before humans inhabited the Earth. But are they always natural disasters? According to the Human-Induced Earthquakes database, there are 766 earthquakes on record that have been directly caused by human activity. The main offenders are geothermal extraction, causing 8% of all human-induced earthquakes, conventional oil and gas extraction, causing 14%, and water reservoir impoundment, causing 22%. But coming in at number one, causing a whopping 37%, is mining. So if Australia has been mined since 1841, how has that affected its geology? A large portion of Newcastle's history revolves around brown coal. Most of Australian coal was formed during the late Permian-Triassic period. During the Permian-Triassic period, Australia was connected to Pangaea. Evidence of this can be found in Newcastle through fossils found in the coal known as Glossopteris. This links Australia to India and South Africa. The Newcastle area has been used by humans for years, being home to the indigenous Awabakal and Warimi tribes, famously in an area now named Nobby's Tuff, which they use the sharp rocks for cutting and scraping tools. Nobby's Tuff is a site of geological interest as there are many volcanic dikes in the area, and the area was also noted for its many coal veins. When Europeans first arrived in Newcastle, the abundance of coal was noted by Lieutenant Shortland in 1797. Coal mining commenced in Australia in 1841, being Australia's first major export. Newcastle being one of the two major ports, along with Wollongong. Coal has been mined there ever since. In the minute that has passed, coal has been mentioned 7 times, indicating how important coal was to Newcastle's geological history. But from 10,000 years ago until 200 years ago, when the mining first commenced, Newcastle had a relatively stable tectonic activity. However, in the last 150 years, the seismic activity has significantly increased, most evidently in 1989. Earthquakes are surprisingly common in Australia. Although our country does not sit on the boundary of tectonic plates, the Indo-Australian plate on which we lie is continuously being pushed north against the Philippine, Eurasian and Pacific plates. This places stress on upper continental crust, which influences seismic activity. The mining project in Newcastle involves unloading substantial amounts of coal and groundwater from the Earth's crust. This activity weakens the crust, allowing the stresses to form a deformation. Destabilization of the continental crust directly increases the prevalence of earthquakes. The earthquake struck Newcastle City at 10:28 a.m. on the 28th of December 1989 and registered at 5.6 on the Richter scale. The earthquake only lasted 5 to 6 seconds, but there were a total of 13 deaths, 162 people were hospitalised, and over 500,000 buildings were damaged. Let's go back 3 minutes before the earthquake and see what happened.
I have goosebumps, people!
Terrible.
Mate, let's go call the 2 at work immediately.
The earthquake caused a significant amount of structural damage to Newcastle and the surrounding area, leading to 500,000 buildings being damaged and many needing to be demolished as they are no longer structurally sound. The total financial cost is estimated to be $4 billion and 69,564 insurance claims were made. A large reason for the extensive infrastructural damage was a result of poor building standards, as many buildings had a low-quality, unreinforced masonry. This exacerbated the impact of earthquakes damaged, particularly as the buildings at this time were old. The Newcastle earthquake sparked a change in the Australian National Building Standard to ensure that the risk of earthquake was considered in infrastructure construction. This nationwide change, coupled with a greater understanding of Newcastle's geology of the area and human-induced earthquakes, has reduced the risk of such extensive damage should such a disastrous earthquake occur again.